Welcome back, my dear students. As we are studying the belt drives here, some important terms will come in this chapter here that are related to the belt drives or belts here. The one important that the term it will comes, that is called as the velocity ratio here. That is called as the velocity ratio. It is sometimes it is also called as it is noted by I here in some books. It is in some books it is taken as a VR like that, and it is also called as the transmission ratio. Transmission that ratio here now, and also it will be called as the speed ratio here. We can call it is that is a speed ratio like that here now. So variety of that calling is there. Speed ratio, transmission ratio, velocity ratio, all are same here. And here, what is this? What is this that velocity ratio? So to study this, we will take this is the driver here. Yes, this is the driver, and this is the follower here. Yes, this is the follower here. One thing we have to note, take a note here now. The driver is usually the driver we are preferring a smaller size, smaller diameter. Why it is? We will see next here now. If it is more economical to choose, the driver is a smaller diameter one. So therefore, this is the driver here. Yes, this is the driver. So driver means, as I have told, it is connected to the source. From that we want to transmit the power here. So next, these two are connected by that the flat belt here now. Just for example, to study this, I am taking this is the flat belt, and this is the direction of this belt here now. The direction of these two pulley here now. The shaft is there in both the cases here now. So next here, see this rotation here now. Driver, it is covering how much angle here? If it is one rotation, it will cover how much angle? 360 degree angle. Correct one? Here 90 degree, 90 degree, 90 degree, 90 degree. Total it will covers. If it will rotates one revolution, it covers 360 degree angle. Coming to the follower here now, this follower will also covers 360 degree angle. Means what? What is the meaning here now? That is angular velocity. Linear velocity means meter per second, as we have studied. Linear velocity, how much distance linearly in a straight line it is a moving per unit time, that is a per second, meter per second here now. That is called the linear velocity. Angular velocity means how much angle it will covers per second, it is radians per second here now. So that angular velocity it is there here now. It is same for the driver as well as follower here now. So what I will take the notation, usual notation I will take here now. For the driver, I will take this, the diameter is d1 here, and its speed is there. Speed means revolution per minute, RPM, revolution per minute. Its speed is n1 I will take. It is in RPM here, RPM, revolution per minute, per 1 minute. It is in RPM here now. So we can make it RPS also, divided by 60. If we are done, here is per minute is there. That minute, if you multiply into 60, you will take a RPS, revolution per second, it will comes. Similarly, for the follower, it is D2 and N2 here now. Next, what is the formula for the angular velocity here now? Because the velocity of the driver is equal to angular velocity of the follower here. So therefore, what is the formula for that angular velocity with respect to the diameter we will take here now? It is the pi dn by 60 here now. This is the formula we are using here now. Pi dn by 60. So therefore it is pi, here it is constant, d1 n1 for the driver divided by 60. Why it is 60 I am taking here now? Because it is in RPM. To convert this into RPS, it is a 60 is there. It is unit conversion. So therefore it is in the, for the follower it is pi d2 N2 divided by 60 here. So here pi into 6, pi divided by 60, pi divided by 60 will get cancelled. So therefore it is d1 n1 is equal to, it is d2 n2. So I will write this one in this way, n1 by n2 means n2 I will take this side here. No? This is equal to, it is d1 divided by d2 here. This is called as the I means it is the, this is called as the velocity ratio. It is called as the velocity ratio, speed ratio, transmission ratio. N1 divided by N2 is equal to D1 divided by D2. Sometimes it may write the follower upward, N2 divided by N1 is equal to, it is the D1 divided, that is D2 divided by D1 here now. So sorry, N1 divided by N2 and it is D2 divided by D1. Sorry, it is D2 divided by D1. Sometimes we can write in terms of follower also. So that is not economical here now. As I have told, it has to be written N1 divided by N2 is equal to D2 divided by D1 here. What we can understand from this velocity ratio here now, the speed of the see here, the speed N1 is here, D1 is here. N1 is in the numerator, D1 in the denominator in the other side here now. So therefore N1 speed is there, N speed is here indirectly proportional to the diameter. Means what? If the diameter increases, the bigger pulleys here now, the speed will be decreases. Revolution per minute, that is decreases here. That is, speed is inversely proportional to the diameter. So therefore it is I is equal to N1 divided by N2 is equal to D2 divided by D1. It is there. So therefore it is called as the speed ratio or else velocity ratio here. So next, that under some important terms are there here, no? Important terms we are studying. That is called as the slip here. Slip here. Slip. What is this slip here? We need to study this slip here. What is slip? Slip means slipping here like this. So if the belt is moving in a circular pulley here like this, it may slip like this. It may slip like this here. No? It will slips out. When it will slip out from the pulley, that belt, then power will not be transmitted. It is coming out from the pulley here. No? So that slipping is very less, or zero slip is there in case of the V belt drive. There is a grooves are used here. Grooves are used in that belt is moving here. No? It will not slip at the side because side support it is there here. No? It will not slip out. But whereas in case of the flat belt, definitely it will slip here now. So why it will slip? What is the reasons are there here? Then what is the slip? Slip means what? Slip means it is nothing but it is the relative motion. It is a relative motion between the belt and the pulley. What is the relative motion means? The pulley is rotating one speed or one motion. It is a rotary motion. Belt is also that is moving on the pulley with one motion here now. If both are moving in the same motion, then relative motion is zero. Then there is no question of slipping here. The belt will not slip out here now. If the relative motion will exist more, means the pulley is rotating with some different motion and that belt is rotating with a different motion with a different speed, definitely the different motion here. So definitely there will be the slip will occurs here. That is the relative. That's why slip is the relative motion between the belt and the pulley here. This slip may occur in case of the driver side as well as in case of the follower side. Follower side, driver side, both the sides the slip will occurs here. So therefore this slip will be, that is noted by the symbol S. Yes, and it is measured in terms of percentage here. It is measured in terms of, that is in terms of percentage we are measuring the slip here now. So next one, the reasons. What are the reasons for this here now? For the slip, what are the reasons? Why this slipping of the belt will be takes place from the pulley here? One reason here, that one is the more smooth here. More smooth pulleys here. The pulleys are very high smooth, it is there. Very high finished pulleys are very smooth, it is there. After reuse, after using for a long time, then pulley will becomes very smooth. At that time belt will slip. This is one reason here now. And next one is more frictional grip here now. More frictional grip. Less frictional grip here now. Less frictional grip or frictional coefficient means there will be the friction between the belt and the pulley. That is the main agent to transmit that power here now, from the pulley to the belt or belt to pulley, whatever it is there here now. So the frictional grip or a coefficient of friction is less, then definitely slip will occur here now. The next one is the tension difference. As we know, tension at the tight side tension here T1 and slack side tension here now, it is a T2 here now. T1 is greater than T2 here now. So the difference between the tension T1 minus T2 is very large here. T1 minus T2, very high tension at the tight side, very low tension at the slack side. At that time also tension huge difference will occur, then also belt will slip here. So next one is how to avoid it here. How to avoid this slip here now. That means how we can avoid or how can we reduce it here now. One thing we can avoid this one now by replacing the belt, it is there here now. And another one is if we use jockey pulleys, additional under one pulley, jockey pulleys, then we can by that we can increase that frictional grip between the belt and the pulleys. So therefore we can decrease the slip here now. How this one now jockey pulleys here? For example, this is one pulley here. For example, it is a driver pulley or the follower pulley here. The driver that pulley is, for example, this is a smaller one. It is called the driver pulley here. So here will be the jockey pulley. See here, it is the jockey pulley. Jockey pulley, it is very nearer to the smaller pulley here now. So what is happening? The belt will comes here and see here. It will increases the contact here like this. So this is a idle pulley actually. This is not taking a part. This the jockey pulley, it is not taking a part in the power transmission, but it will take a part to increase the contact, contact between the belt and the smaller pulley here. So therefore, by this also we can reduce that slip here now. So we can increase that frictional grip like this here now by using the jockey pulley here in this case. The next one, as it is measuring in terms of percentage here now, how to account it here now? How to account its slip in case of the velocity ratio? It is a very important term here now. Velocity ratio is what for the drive? It is N1 divided by N2 is equal to, it is a D2 divided by D1 here now. So always this will be accounted in the denominator here. It will be accounted in the denominator. If it is a total slip, in case of the driver as follower, if it is a total slip is S is there here now. In terms of percentage here now, it is a total slip it is there. How to account it here now? N1 divided by N2 is equal to, it is D2 divided by D1 in bracket here. In bracket 1 minus S divided by 100 here. S is in percentage. For example, 20% slip is there. Then what we have to take? S is equal to 20. This 20 divided by 100, 0.2, 1 minus is there. Here, this is how we are accounting total slip here now. If it is, the slips are at for the driver and followers are different. If for example, S is the slip for driver here and S2 is the slip for the follower here now. In case of the follower is there. Then next one is I is equal to, how to account it? N1 divided by N2 is equal to D2 divided by, it is D1 in the bracket 1 minus S1 divided by 100 into, again here into 1 minus, it is S2 divided by 100 here. Shall I write one? I can write here now. Once again, D2 divided by D1, it is 1 minus S1 divided by 100 and bracket 1 minus S2 divided by 100 here. If we account the slip separately, if we account the total slip separately, how to account it in case of the velocity ratio here? Why? By considering this slip, what happens? Velocity ratio, what happens? Without considering this slip, the velocity ratio is, for example, I here. After considering the slip, that velocity ratio is I will take here. So definitely I is greater than the is here. Means what? The slip is there, it will reduce the velocity ratio. It will affect the transmission of the power here now. So therefore, this is about the slip here now. The relations for the slip, how to account it, what do you mean by that, reasons and all these things. This is about the slip. So we'll see in the next video lecture, the topic of this one. Thank you very much.